Hi, Assalamualaikum and good evening. Today, me and my friend gonna present subject STA 108, which is the relationship between students' height and shoes size. Let's get meet our groups. First, my name is Muhammad Arzainil bin Razmi, and my friend is Muhammad Zarif bin Muhammad Sharil and Muhammad Arif Irfan bin Adri Azrin. Also, Muhammad Adi Hafiz bin Zaki.
Project overview. First is purpose of the study. To investigate whether a statistically significant relationship exists between a person's height and their shoe size. Second is scope of research. 30 respondents from UiTM University and the general public focus on height and shoe size. Methodology. Sampling method. Simple random sampling. Tool Google Form. Analysis, descriptive stats, histogram, scatter plot, correlation and regression. Project conclusion. Height is moderately predictive of shoe size and can assist in sizing system. Introduction. People always question if body proportion are related or not. The correlation between a person's height and shoe size is a classic example. The purpose of the study is to look into the connection between shoe size and height. This research explores whether taller people have bigger feet to figure out whether there is a significant correlation between the two variables. Data will be collected from a chosen sample and statistically technique will be applied. Objective of the study. First, to determine the strength and direction of the correlation between height and shoe size. Second, to find the regression line representing this relationship.
Significance of the study. First, help improve retail size prediction system. Second, useful in footwear and fashion design. Third is exchange healthcare modeling. Fourth is support automate recommendation in e-commerce. Okay. Next is limitation of study. First, this study only involves 30 students. Second, this study does not include factors like gender, age, and foot width. Methodology. First is population. Population in UiTM capacity and general public. Second, sampling. Simple random sampling. Third is sample. 30 randomly selected student. Four is tool. Google Form survey.
In this research, there's have three variables. The first one is gender. Gender's type is qualitative. The measurement level is nominal. The second one is height. The type of height is quantitative. The measurement level is scale. Okay, the lastly, shoe size. The shoe size type is quantitative. The measurement level is scale. As you can see, here is data analysis. The left one is the histogram of height of respondents. The right one is the histogram for male, female, and the program, which is AS124 and non-UITM.
T is data analysis. You can see at left is histogram of shoe size of respondent. And right above is model summary. And down is coefficient.
Okay, now we're gonna talk about descriptive statistic. So statistic mean for height is 160.93, and for mean for shoe size is 39.17. Mod for height is 158, and for shoe size is 40. First quartile for height is 156, and for shoe size is 36.75. And third quartile is 169, and for the shoe size is 40.75. Standard deviation is 14.606, and for shoe size is 3.01. Skewness for height is negative 2.7, which is to the left, and for the shoe size is 0.37, which is positive, it will go to the right. And now for the median for height is 162, and for the shoe size is 39. And lastly, coefficient of variation, height is 8.88% and shoe size is 7.81%. Now, we're going to talk about correlation and regression analysis. Correlation result is 0.619, moderate positive relationship. Interpretation, taller individuals tend to have a larger shoe size. Regression line equation, y equals to 17.846 plus 0.132x. Each 1 centimeter increase in height increase predicted shoe size by 0.132 euro size. Okay, now I'm going to talk about coefficient of determination. R square equals to 0.383. Only 38.3% of the variation in shoe size can be explained by height. Remaining 61.7 is influenced by other factors such as genetic, foot structure, and gender. Okay, now we're gonna look at the scatter plot interpretation. As you can see at the scatter plot to the right, scatter diagram shows that positive trend between height and shoe size, moderate clustering around the regression line, support prediction, though not perfectly strong.
The conclusion of the research: a moderate positive correlation was found, R equal to 0.619. Regression line y equal to 17.846 plus 0.123 is useful for estimating shoe size, while height gives some predictive value. It's not the only factor.
Recommendation for future research. First, use a larger and more diverse sample. Next is add other predictive variables like gender, age, and foot width. Third is apply finding in retail, footwear design, biometric research. Last is incorporate into machine learning system for product recommendation.
The conclusion of the research: a moderate positive correlation was found, R equal to 0.619. Regression line y equal to 17.846 plus 0.123 is useful for estimating shoe size, while height gives some predictive value. It's not the only factor. Interpretation of slope. The slope indicates the rates of change in shoe size for every 1 centimeter increase in height. In this context, for every additional 1 cm in height, a person's predict shoe size increases by 0.132 EU. It reflects a positive relationship between height and shoe size. The taller the person, the larger the shoe size, though not perfectly. Example of prediction using the regression lines. Regression equation shows size equal to 17.846 plus 0.132 times height. Example prediction. Let's predict the shoe size for someone who is 117 cm tall. So the shoe size equal to 17.846 plus 0.132 times 117. So it's equal to 14.29. So overall, a person who is 170 cm tall is predicted to wear a shoe size of approximately EU 14.29. We can apply this same equation for any height value to estimate the shoe's size. I guess that is all from us. Thank you for listening to our topic. Bye. Thank you, madam.